Hello, Sir Fauzi. My name is Muhammad FAIZZUL bin Jeffrey from DKA 3A. On 18 October 2021, we are doing Atterberg limit test. Before we start, I would like to introduce my group member. The first group member is Arthur Davidson Naga, and the second one is Waybyern Anak Briki, and the third one is me, Muhammad FAIZZUL bin Jeffrey, and the last one is Muhammad NAJIB Muhammad. So today I will explain a little bit about objective. The objective is to determine the value of liquid limit, plastic limit, and plastic index of soil. The Atterberg limit test accuracy define the boundaries between this state using moisture content at the point where the physical changes occur. The test value and derived index have direct application in the foundation design of structure and in predicting the behavior of soil, infill, in embankment, and pavement. The value assess shear strength, estimate permeability, forecast settlement, and identify potential expensive soil. So that's all I want to explain. I will pass the next slide to my next group member is Muhammad Najib.
Thank you, Muhammad FAIZZUL. So, firstly, I want to introduce myself. So, my name is Muhammad Najib Muhammad. So today I'm going to present about the apparatus. So the first apparatus is liquid limit device, or we call it Casa Grande. Next is porcelain to put the soil mixture. Then flat grooving tools with gauge to make the line. Next apparatus we need is add moisture can to put the mixture of the soil. Then we need balance to wet the soil. Next apparatus is glass plate to roll the soil mixture in the plastic limit test. Then the next apparatus we need is spatula to take out the soil mixture. Next we also need the bottle with distilled water for the mixture of the soil. And lastly, for the apparatus is drying oven. Okay, that's all from me. So next, I will pass to my friend Waybyern to explain about the procedure. Thank you.
Thank you, Muhammad Najib. My name is Waybyern and I'm going to continue on the procedure of liquid limit. Okay. So first of all, we will sieve the soil by using number 40 sieve and take roughly 3/4 of soil and place into the porcelain dish. The soil is mixed with small amount of distilled water until it appears as a smooth, uniform surface paste. Okay. Next, 4 moisture cans is weighed and recorded the respective weight and can number on the data sheet. Okay, now the liquid limit apparatus is adjusted by checking the height of drop of the cup. Point on the cup that come in constant with the base should rise to a height of 10 mm. The block on the end of the grooving tool is 10 mm high and should be used as a gauge. Use the cup by practicing and determine the correct rate to rotate the crank so that the cup drops approximately 2 times per second. Now, okay, place a portion of the previously mixed soil into the cup of the liquid limit apparatus at the point where the cup rests on the base. Squeeze the soil down to eliminate air pockets and spread it into the cup to a depth of about 10 mm at its deepest point. The soil pad should form an approximately horizontal surface. Okay. Okay, next, carefully cut a clean straight groove down the center of the cup by using the grooving tool. The tool should remain perpendicular to the surface of the cup as the groove is being made. Use extreme care to prevent sliding the soil relative to the surface of the cup. Make sure the base of the apparatus below the cup and the underside of the cup are clean of soil. Turn the crank of the apparatus at a rate of approximately 2 drops per second. Count the number of drops and takes to make the 2 halves of the soil pad come into contact at the bottom of the groove along a distance of 13 mm or 1.5 inch. If the number of drops exceed 50, then go directly to step 8. and do not record the number of drops. Otherwise, record the number of drops on the data sheet. Okay, take a sample using the spatula from edge to edge of the soil pad. The sample should include the soil on both sides of where the groove came into contact. Place the soil into a moisture can and cover it. Immediately weigh the moisture can containing the soil, record its mass, remove the lid, and place the can into the oven. Okay. Leave the moisture can into the oven for at least 16 hours. Place the soil remaining in the cup into the porcelain dish. Clean and dry the cup on the apparatus and the grooving tool. Remix the soil specimen in the porcelain dish. Add a small amount of distilled water to increase the water content so that the number of drops required to close the groove decrease. Okay, now repeat step 6, 7, and 8 for at least 2 additional trials, producing successfully lower numbers of drops to close the groove. One of the trials shall be for a closure requiring 25 to 35 drops, one for closure between 20 to 30 drops, and one trial for a closure requiring 15 to 25 drops. Determine water content from each trial by using the same method used in the first laboratory. Remember to use the same balance for our weighing. Now I am going to pass this slide, this presentation to Arthur Davidson.
Thank you, Waybyern. So for the plastic limit test, the first procedure is wet the remaining empty moisture cans with their lids, and the respective weight and can numbers was recorded on the data sheet. Next, remaining 1/4 of the original soil sample is taken and added with distilled water until the soil is at consistency where it can be rolled without sticking to the hand. Jip play. Form the soil into an ellipsoidal mesh. The mesh between the palm or the fingers and the glass plate is then rolled. Next, use sufficient pressure to roll the mesh into a thread or uniform diameter by using about 90 strokes per minute. The thread shall be deformed so that its diameter reach 3.2 mm, taking no more than 2 minutes. When the diameter of the thread reach the correct diameter, pause dip. Break the thread into several pieces. Knit and reform the pieces into ellipsoidal meshes and re-roll them. Continue this alternate rolling, gathering together, kneading and re-rolling until the thread crumbles under the pressure required for rolling and can no longer be rolled into a 3.2 mm diameter thread. Gather the portion of the crumbled thread together and place the soil into moisture can and then cover it. If the can does not contain at least 6 grams of soil, add soil to the can from the next trial. Then, immediately wet the moisture can containing the soil, record its mesh, remove the lid and place the can into the oven. Leave the moisture can in the oven for at least 16 hours. Finally, repeat step 3, 4, and 5 at least 2 more times to determine the water content from each trial by using the same method used in the first laboratory. And remember to use the same balance for all weighing. So this is the data for the liquid limit test for sample A, B, C, and D. In this data, we recorded the moisture can, weight of empty clean can with lid, weight of can, lid, and moist soil, weight of can, lid, and dry soil, weight of soil solid, weight of water content, and last but not least, number of drop. For sample number A, we get the number of drop 60. For B is 30, 38. C is 30, and last but not least, D is 20. Next, for plastic limit, we only carried out for 3 sample, and then we recorded the weight of empty clean can with lid, weight of can, lid, and moist soil, weight of can, lid, and dry soil, weight of soil solid, weight of water, and last but not least, water content. For sample A, the water content is 9.09%. B is 30%, and last but not least, C is 18.18%. So that's all from us. Thank you.